Hi everyone. So today we have a Div1 plus Div2 round and I'll be participating in Div1. So yeah, I'll be doing that post-contest discussion thing again today with Parth and he'll be participating in Div2 today. So like if he's able to solve A, B and C of Div2, so we can discuss that and I'm pretty sure he'll be able to do that. Apart from that, I've also created my own Discord server. So like if you haven't already checked it out, then I'll leave the link to it in the description. So you can join it. Now the main purpose of joining a Discord server would be to have more informal conversations with me because like it's not really great to have informal conversations in the YouTube comments because that just creates a lot of spam and everybody who's watching the video has to read through those messages. So yeah, you can join the Discord server and I'll leave the link to it in the description. And let's see who's registered for it and who's registered for Div2. Okay, I cannot see who's registered for Div2 here. So I can only see the people who have registered in the Div1. Okay, so the main aim here will be to solve at least two problems. Now, two problems in Div1 is really difficult for me. Like I'm hoping I'm able to solve at least one here. But yeah, let's see how it goes. And I think I'll get my pen and paper, yeah. Okay, so it's about to get started and here we go. So first problem, a sequence of brackets is called balanced if one can turn it into a valid math expression. Okay, you're given a binary string s of length n, construct two balanced bracket sequences a and b of length n such that for all I less than equal to n. Okay, si equals to 1, then ai equals to bi. If si equals to 0, then ai is not equal to bi. Okay, so here is the thing, and both of them should be balanced. Okay. So if there is a 1, then ai has to be equal to bi, right? And if there is a 0, then ai should not be equal to bi. Okay. Okay, so the very first thing here is that, let's look at it case wise. So the very first letter, it has to be 1, right? If the first letter is not 1, then we cannot create it because then one of them has to be like this. And that will not, form a valid bracket sequence. So we can put an opening and an opening bracket here. Now let's say they both are 1 again. Okay. So what we need to make sure here is that whenever there is a 0, yeah, so whenever there is a 0, I have to put an opening bracket here and a closing bracket here, right? Now this can be reversed. Like there can be a closing bracket here and an opening bracket here as well. So the thing here is that all these zeros are only of importance here because then we can form our ones accordingly, right? So if there is a 0, so like let's say here is a 0, here is a 0 and here also there is a 0, right? Okay. So then we need to put an opening bracket here and a closing bracket in one of them, right? So without loss of generality, we can put it in any of them. Like let's say in the first one I put a opening bracket and in the second one I put a closing bracket. Okay. Now here what should I put? Here is the thing. Also, like when they're telling us that there is a 1 at all these places, like we are assuming that this is the first 0, okay? So all of them have to be same in this and this. So like the substring till here will be the same in both of them. And this is the first point that they will differ. Okay. Now the thing is that the substring from here and here has to be same as well. So in other words, we need to form, we need to form such a bracket sequence such that for all the places that are ones, we can do anything that we want. But for all the places that are 0, we want that the whole sequence that is this, let's say here we had an opening bracket, then it should be valid even if we put a closing bracket here. That is the whole thing. In other words, we need to construct this whole string such that on all these zeros, there has to be a different character. And that should be a valid sequence. Okay. So let's say I consider this string till here, then both of them are same. So what I do, on the very first one I put this opening bracket and on the second one I put this closing bracket. Okay. Now here also they are same, right? And then I need to put a closing bracket at this place and an opening bracket at the same place. So now the thing is, where should we put? Should we put it here or should we put it here? Okay, so what are the constraints on these numbers? They are up to 10 to the power 5. Okay. Okay, I'll have to walk around and think about this. Okay, so the very first intuition that I'm getting here is that if there are odd number of zeros, then maybe this is not possible, right? Uh, so basically what I can do is, let's say I have these zeros, and on the very first place, in the first string I can put this, and in the second string I can put this. Now for this prefix part, what I can do is I can maintain it in such a way that it has one extra opening bracket. So what will happen at this point is that in the first string there will be two opening brackets, and in the second string there will be zero now. Why? Because obviously this is getting close, right? And then this all will be same, this all will be same. Yeah, this all will be same here. These are all ones here. And for this very next zero, what I do is I close this one and I open this one. So what will happen here is that this was +2 and this will become +1, right? And this will become +1 again. So the thing that I'm doing is that after even number of zeros, I'm maintaining this thing that there will be one extra +1 on both of them. And in the end, we'll be closing that +1 if there is a 1 at the end. So this works in case of even number of zeros. But what about what if there are odd number of zeros? So let's say there is only 1 0. Then we cannot do anything, right? Because in order to convert one bracket sequence into another, you need to flip exactly two of them, right? You need to flip exactly two of the zeros. Okay. And if there are even number of zeros, I think this is always solvable if there are even number of zeros, provided there isn't a zero in the very start and there isn't a zero at the very end. Okay, so if s at 0 equals to 0, or s at n minus 1 equals to a 0, then we know that this is not possible. And we have to print yes and no, right? Else what we do is, else we count the number of zeros in the string. Okay, so if either of them is true, then this is not solvable. Else what we do is, okay, let's just maintain a character array. So if there is a 0 and counter equals to 0, that means you have to put an opening bracket in the first one. What do? We put an opening bracket in the first one and we put a closing bracket in the second one, right? Else what do? Else we do and we do counter or equals to 1. Else we put a closing bracket in the first one and an opening bracket in the second one, right? Yeah, this seems fine. And after that we just need to construct that whole string, right? Okay, so if there are all ones here, then to create a +1 from them, but it is not always possible to create a +1, right? Or is there always a way to create a +1? So we want n by 2 opening brackets and n by 2 closing brackets, right? So how much have we used? Sum by 2. We have already used this much, so we can start putting the opening brackets from the very start. And is n always even? Okay, n is always even. Fine. So if we have this, then if remaining is greater than 0, and in the end we'll also need to check whether they are fine or not, because if they're not, then we'll have to print no. Okay, let's see how it performs on the sample test cases. Okay, why is it taking such a lot of time? Okay, it should have been S1 and S2, right? Okay, is there some other thing that is wrong in this? Oh, okay. I have passed both the strings together. I mean both the vectors together, so I'll have to pass it like this. Okay, why did it take such a lot of time? And there has to be... Okay, else we have to print no. So I think I'm doing some mistake here. So I'll quickly remove the first test case here and I'll try it for the second one, which is giving me a no. And here is what we are getting. So this seems to be valid. 1, 2, 3, 4. Okay, there are some unnecessary... Okay. So why is this not valid? 1, 2, 1, 2. Okay, a lot of time has been wasted, but still, let's see. So what I did here was I closed that one. So is there a +1 after this point? Yeah, there is a +1 after this point. Plus... So we had a 1 and a 1, then we had a 2 and a 0. Fine. Then we had a 1 and a 1 again, then we had 2, 2, then we had 3, 3. Then we had 2, 4. Then we had 1, 3, then we had 0, 2. Okay, so first of all, we've used sum by 2 times of the opening and of closing brackets. So the remaining is oh, did I not just do a counter XOR equals to 1 here? Was this the problem? Oh, okay. I think the what I did was fine already. So there was a typo here, and let's see how it goes now. So it seems to be fine, and I'm submitting it now. I hope the logic is clear, but still, if it is not clear, then I'll obviously explain this in the post contest discussion, provided this works, obviously. Okay, wrong answer on test 2. Let's see what else are we doing wrong here. So here is the sum. I'm increasing it by 1, okay. So if the first character is a 0 or the last character is a 0 or sum modulo 2 is not equal to 0. Oh, why did I do just a break here? It should have been continue, right? Oh my god. This is pathetic. So let me just first of all quickly check my code again because I don't want to do a lot of wrong submissions on the very first problem itself. So, okay. Rest seems to be fine to me. Okay. Finally. And I'm really very happy for this one. Okay. Seems like Galen Colin submitted 3 wrong submissions here. So obviously he'll be doing probably 3 or 4 here. So yeah, I cannot compare myself to him obviously. So moving on to problem B. And I was really very scared as soon as I got a wrong answer on test 2 because that would have meant like if I wouldn't have been able to do this first problem, that means like my rating would have been like minus 200, I would say. But yeah, okay. So reading the problem B now. Alice and Bob are playing a game. There are n into n. There is an n into n grid, initially empty. We refer to the cell in row I and column J by ij. There is an infinite supply of tokens that come in 3 colors. Okay. Okay, fine. The game proceeds with turns as follows. Each turn begins with Alice naming one of the 3 colors. Let's call it A. Then Bob chooses a color B, which is not equal to A, chooses an empty cell and places a token of color B on that cell. Okay. We say that there is a conflict if there exists 2 adjacent cells containing tokens of the same color. 2 cells are considered adjacent if they share a common edge. At any moment there is a conflict, Alice wins. Otherwise, if n square turns are completed without any conflicts, Bob wins. Okay. We have a proof that Bob has a winning strategy. Play the game as Bob and win. The interactor is adaptive. That is, Alice's color choices can depend on Bob's previous moves. Fine. and n can be up to 100. Okay, seems fine. So let me just quickly drink some water and I'll be right back. Okay, so I am back. And we cannot put a color that, has been chosen by Alice. Okay. Okay, we don't want the adjacent colors to come together. Okay, so let's consider it like this, that we have this whole grid and we've already filled all of it. But let's say only the last cell is remaining, right? So if we have this whole grid and let's say all of them are filled and only this cell is, let's say, remaining. So if we have a green, or let's consider it like this, that if we have a 1, 1, 1, 1, then if Alice chooses 1, then we are done. If Alice chooses 2, then we are done. If Alice chooses 3, then we are done, right? Like this is for the last point. But can I do it like a chess coloring? So like if I choose, let's say 1, let's say Alice chooses 1 and I choose 2 and I put it here. Okay. And then I think a chess coloring should work, but let's see. So if Alice chooses 1, then I choose 2 and I mark it here. Okay. So at any point, if I get a chance to mark a 2, then I mark it on these places, right? Like a chess coloring. Whenever I get a chance to mark a 2, I do it like this. And let's say he says 2, then I have to pick another number. Then whenever I get a chance to mark a 1, then I mark it here, right? And whenever I get a chance to mark a 3, then I can mark it here. So what I can do is I can pick two colors and I can say that on let's say even places, not even, I would say I plus j mod 2 I plus j should be even, and on those places I can mark let's say Alice gives me 1, okay, then I can mark a 2 at this place. Now I have decided that all these even places I will mark a 2, okay. Now let's say she gives me 2, then I know that I can mark a 1 or a 3 anywhere I want. So this should work, yeah. This should work. So basically the idea here is to color it like a chess coloring. Okay. So I can pre-decide that as well. If she gives me a 2, but what if I'm already done marking the places? Like that is also an issue right here. What if I'm already done marking all these 1s and 3s and then she gives me a 3 again? So if she gives me a 2, then what do? Then I will have to mark it as a 1 or a 3, right? And that will obviously conflict. Okay, let's consider a 3 cross 3 grid and let's try to mark here, or rather I should consider it like this. Right. Okay, I have to consider 3 cross 3, right? Okay. So the entire thing here is that for any place, let's say this is the I comma jth place, then I cannot have both the other colors coming here. Like I cannot have 1 and 2 here. All the neighbors, or rather I should say like, yeah, the neighbors only, they should be surrounded by they should have the same color. Because if they have a different color, then we know that what she will do is she will keep calling, let's say I have 2 and 3 here, then she will keep saying that I give you 1, 1, 1, and what will happen eventually is that I will have to fill up this cell, and that will either go in 2 or 3, but that will conflict. So for any cell I cannot have like both type of numbers here, right? So let's say she gives me a 2 and I mark it here 1. let's say I mark a 1 here. And then if she gives me a 1 again, can I do it like this, that I keep marking the places like this? Then this and then this. Like, will it help me? If she gives me a 2, then I mark a 1 here. If she gives me a 1, then I can mark a 2 here. But then if she gives me okay, so another thing that I can do here is, okay, so if she gives me a 1 or a 3, then I can mark a 1, right? Like that chess coloring logic was, I think, fine. So if she gives me any number from 1 and 3, then what I do is I try to mark a 2 here. Right, but yeah, the logic was failing when in the end she does not give me a 1 or a 3 and I have to mark a 2. Okay, I will have to think about it on pen and paper again because this is getting really bad typing. I mean, making figures on OneNote. Okay, so what I'm able to think here is simply this, that let's consider this question that if we have only 1 and 2s. Okay, so if this is my grade, let's consider it like this. Let's consider a 4 cross 4 grid. So every time she gives me a 1, I keep marking my 2s on the even places. So let's say I do it like this. And if she gives me let's say a 2, then I keep marking my 1s. Right, I keep doing this. And at one point, and if she gives me a 3, I can mark any of them. Like whichever is not complete till now, I can mark any of them. So at one point, we will definitely have the board hole occupied by 1s or 2s, provided that if we insert anything here, then it won't match. That is, if they give me a 2, then I can obviously mark a 3. And if they give me a 3, then I can mark a 2. And then if they give me a 1, okay. So if 1s are completed and they still give me a 1, that is fine. If all, let's say if all the 1s are completed and they give me a 1 again, then I can mark a 2. I'm done. If they give me a 2, then I can mark a 3. It does not hamper me. Yeah, so at least one of them has to get completed. So I'll be coloring it in the form of a chess coloring with 1s and 2s. Yeah, let me just remove that. So the logic seems to be fine to me here. So as long as one of them gets completed, we are done. Right, and let's just make our set of pairs. Or rather not set, let's keep it a vector only. I plus j mod. So I'll be having two vectors here. And there is n square here, right? But it does not depend. v1.pb, I do I comma j. v2.pb, I comma j. Or rather, I should just consider them whole. Right, let me just debug them once. Okay, is there an issue here? 1 comma 2, 2 comma 1. Yeah, seems to be fine. So I'll be inserting 2 on the even places. So int I equals to 0, j equals to 0. Right, so if a equals to let's say 1, so that means I can insert a 2. So if a equals to 1, right, if a equals to 1 and I is not equal to n1, see out 2, and how do we need to print it? Let's see. Okay, fine. See out 2 and we'll do v1 at I dot ff, v1 at I dot ss, and we'll do endl to just flush the output. Right, else what do? Else we do cout 3 v2 at j v2 at j dot ss. Then let's say a equals to 2. So then we do the same thing, but we do it in a reverse way. So if j is not equal to n2, yeah, so this condition, like the else part, will only be used when, okay, this should have been d2, right? It will be only used when one of them is completely filled, and if one of them is completely filled, then we know that we can fill the rest of them as we like, right? So this should be v1 at I dot ss. Okay, seems to be fine, and I'll try to just run it on command prompt because I cannot do that interactive thing here. G plus c dot cpp a dot exe. Okay, so we have to print, we have to give it an input, so I can give 2, and what happened? Okay, I have to give it a number, right? So I give it, how do I construct it? Like I have this 2 cross 2 grid. So what it is saying that on the 1 comma 2 I am putting a 2. Fine. So what I'll do now, I'll try to give it let's say a 1 again. So it says it puts a 3 here. But why did it put a 3 when there were already so there, when there are 2 and 2, then why did it print a 3? It should have printed a 2, right? If a equals to 1 and I is not equal to n1, then you do this. Okay. Okay, let's try to do it again. So we are at 0 and 0. Fine. And it gives me a 2, and let's say I give it a 1 again. Okay, how did it get to 2 at this place? This is, I'm not able to understand this. Oh my god, this should have been. Okay, I'm really stupid. This loop has the same variable name as my I. So let me just make it k. Now it should be fine, but still, let's see. So now it has 2's and 2's, and even if I give it a 2 or a 1, then we are done, right? So if I give it a 1, then it takes a 3. If I give it a 1 again, then it prints a 3 again for me. So this seems to be fine now. And I think I'll quickly check my code for this. So I'm printing a 2, fine, and I'm incrementing, fine. So the first one contains 2's, right? This is fine, okay. And I hope I'm not debugging anything here. And does it also give me an output at the end? Running on test 5, pretest 6, 7, okay, great. Running on pretest 10, 11. Okay, great, yes. So I still don't have a very good rank here. That is because I took a lot of time in this B problem. But yeah, it was a cool problem. Like the idea here was to basically color the whole grid as a chess coloring. So yeah, I'll discuss this in the post contest discussion as well, if some of you did not understand what I did here. So moving on to problem C now, and there is another 1 hour to go, so I should try this one. And in case I'm not able to do this one, then obviously I'll post the video till here only. So there are n cities numbered from 1 to n, and city I has a beauty AI. A salesman wants to start at city 1, visit every city exactly once, and return to city 1. For all I is not equal to j, a flight from city I to city j costs maximum of ci comma aj minus ai dollars, where ci is the floor value, is the price floor enforced by city I. Okay. Note that there is no absolute value. Find the minimum total cost for the salesman to complete a trip. Okay. And let me just quickly see what is happening in Div2, because like that is my actual home. Okay, why did I just open this registrations thing?